Okay, YouTube, in this video we're going to be discussing the absolute value graph. Y equals the absolute value of x is our equation. We would like to kind of observe how the graph behaves, so we're just going to go ahead and start by making a table, and then we're going to generalize this to any equation to kind of be able to look at the equation and make the graph just from the equation, not have to make a table. So we're going to go ahead and start with x and y here, and let's fill in some arbitrary x values. So we say -2, -1, 0, 1, and 2. Now the first thing I need people to recall is this. Remember, absolute value is asking a question. Whatever number we stick in here, we're saying how far away from 0 is it? And that question is pretty profound because distances are always positive. So if we were to say, okay, so for example, we're plugging in -2, so we're taking out our x, we're putting in a -2 inside of here, we say -2. The absolute value of -2 is just 2 because we would say how far away from 0 is the number -2? Well, it's 2 away. So we say, okay, so absolute value of -2 is 2. Absolute value of -1, well, if we plug this in, the absolute value of -1, that'd be 1. Okay. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2, well, that's just 2. Okay, so we've got a nice set of arbitrary points here, and we just want to kind of sketch these, get an idea of what our graph looks like here. So we'll draw on our x and y axes. And we did plug in -2, -1, 0, 1, and 2. And when we did so, we found out when we plugged in -2, we were at a height of 2. Okay. When we plugged in -1 here, we were at a height of 1. So we get -1, comma 1, 0, 0. So it does pass through the origin, this graph. And then it also goes through 1, 1, 1, 1, and 2, 2. Okay. And so this pattern is actually going to continue. So I'm going to go ahead and draw on a curve here. And I know you're saying curve. Well, it's not very curvy. It's not very curvy. As a matter of fact, we say this is a rigid graph. It's very rigid. But this is the graph of, we're going to label this here, y equals the absolute value of x. So there are a few things we need to say about the graph of y equals absolute value of x. And so let's go ahead and maybe we change the color over here. Because if you're taking notes, these are good things to write down. But the first thing you're going to notice is this. It's symmetrical about this line right here. Okay, so we say that it has an axis of symmetry. And this is true about every single absolute value graph. It's going to look like a V, and it's got this axis of symmetry running through the middle. And by the way, if you want to be very, very technical about it, if you were to label the equation of this line, it would be x equals, in this case, 0, but it's an x equals equation. It's a vertical line. Okay. You also notice that that on the right here, okay, if we diverge to the right, you know, if you were to look at, say, the slope of this line here, just going to the right, would go up 1 over 1, or you could say it went up 2 over 2, or so on and so forth. But the bottom line is we can determine the slope of that line going to the right, and that's actually a really important number that we want to deal with today. But this is the basic overall general graph of y equals the absolute value of x. And so before we continue, what I'd like to do is hop over to my graphing program here, and we're going to throw it into here, and we say, okay, so here's the same graph we just got done looking at. You notice that it's symmetrical about that y-axis at the moment, and also there's a slope of 1 on the right. So what I want to do is this. I actually want to generalize this to about any situation. So first thing we're going to do is we're going to kind of block this off over here. I just wanted to look at the general shape of this graph. What I can tell you is this. We tend to say that every absolute value function is of this form. Okay, so we say the general form. Let's write this down. General form of an equation of absolute value. Absolute value, absoluteVal. Okay, and we're going to abbreviate that there. We say every absolute value equation is quite technically of the form A times, now the absolute value quantity has x minus h on the inside, and we say plus k, where our three very important values that we pay a lot of attention to are A, h, and k. And we're going to kind of discover by playing around with these what they affect about my graph. But I'll have you notice this, the very, very first equation that we had done over here, y equals absolute value of x, I do want to point some things out. Like in that instance, we say, well, A is just the coefficient kind of thing of our absolute value bars. So it's the number out front of the absolute value bars. And you'll notice that I didn't see a number out here in front of our absolute value bars, but that doesn't mean we couldn't put 1 times the absolute value of x. So in that case, we said the absolute value over there was 1 times the absolute value of x minus. Now I do want to put in an h value, and you'll notice, excuse me, in the very first graph over here we said absolute value of x. There was no number in here with our x. So we're actually going to substitute 0, because that would be the same thing as y equals absolute value of x. There'd be nothing in here with our x. We write minus 0. Then we need a k value here. We say plus 0. Okay. But these numbers here, they actually tell me something about the graph. Just to be honest with you, we were going to discover this now, but we say this 0 here and this 0 here implied to me that it was going to be centered at the origin, the vertex. Okay, by the way, and by the way, let's go ahead and label that on our picture over here. We say every absolute value graph has a vertex. Okay, and that vertex is at this case 0, 0. But those two zeros over here, 0 and 0, that h and k told me where my vertex was going to be. And then this 1 out front, well, if I kind of look at this as my a value here is h and here's k. That a value kind of told me the slope of the graph to the right of my vertex. We said, remember over here, the slope was 1, up 1 over 1. That a value is what was telling me that. So just to kind of get the hang of these, what we're going to do is we're going to play around with this a little bit. What do you say? Well, what if we graphed y equals 2 times absolute value of x, or y equals negative 2 absolute value of x, or what if I even went y equals positive a half absolute value of x? In each instance here, what I want you to notice is this. We're playing around with the a value out front, a, and what effect does a have on our graph? And so for the sake of time, what we'll do is we'll just come back over here and we'll start graphing them in this program. So we say y equals 2 times absolute value of x. So what I want you to notice is this. It's still, if you can see right here, it still has a vertex, at the origin, but in this case we say it's kind of like skinny, or it was vertically stretched from the original. So if you can see up over here, we say the original one had an a value of 1. Now this new one, g of x, we get to say y equals as an a value of 2. And you'll notice that from my vertex, if I were to drop in some points here, so a point on the vertex, and then we say this point right here, and you were to look at the slope, we'd say it goes up 2 over 1. So what I want you to know before we graph the other two now is that this a value directly is the slope of the right side of the graph. And when I say the right side of the graph, from the vertex to the next point on the graph, that's the slope. We could have chosen a point up here and said, okay, so from point A to point C, it goes up 4 over 2, but 4 over 2, that's still a slope of 2. I'm going to rip those points out of there and we say, okay, so our next graph was this. We said y equals negative 2 times absolute value of x. Now before I hit enter here, let's take a look at what we've been saying is this a value is kind of like a slope from the vertex to the next point on our graph. So this is negative 2. That's the same thing as negative 2 over 1. So what we can imply is this. Most likely, this will still start at the origin. It'll have a vertex at the origin, but it's going to go down 2 and right 1. And since we know it's symmetrical about this vertical line through its vertex, we know it's going to go down 2 left 1 kind of thing. But that slope there tells us how we get from there to the next point on the right side of our graph. And hey, what do you know? Look at this. If I drop in this point right here, we'll call it B. Say it went down 2 right 1. So obviously we've picked up on the fact that this a value is kind of like a slope. It's not m, okay, but we'll say this time we'll go a half times absolute value of x. And so this graph should start at the origin, go up 1 over 2. And you notice it does. I mean, I get these ones out of the way here. From the original, it goes up 1 over 1. This one goes up 1, out 2 to the right. So I think we'll pop back over to Photoshop Elements here, and we're going to say some things about this. But we know, what do we know about the graph of the absolute value of x so far? Well, we'll write down a few things. We'll go in this yellowish color. Actually, green would be fun. We say that every graph of absolute value of x in this form, okay, if I were to write down any notes, this is the stuff that I would write down. It has a V shape. We know that it has a V shape. Okay. We could also comment on the nature of A. Okay. So we say if the absolute value of A, that's interesting, is less than 1, then we say it is wider than the graph of y equals absolute value of x. So I just want to be clear on this. What we're saying is, and if it's bigger than 0 also, if a is a proper fraction, let's write that in, proper fraction. What is a proper fraction? Well, that's where the bottom of the fraction is bigger than the top. So if you can imagine this, if our a value out front here is 1, and then like say I do another graph where this a value is a proper fraction, that would be an instance where from my vertex I would like do more running than I would rising. So if for example, I'm a visual person here. If this is y equals absolute value of x, that graph right there, and let me fix that a little bit. Y equals absolute value of x is this. then from the vertex I'm going to go up a little bit, but out more than I go up. And so what I'm saying is, if A is a proper fraction, you're going to get a wide graph. So what if the absolute value of A, that just means look at the number, don't look at the sign, whoops. If the absolute value of A is bigger than 1, then we say we have a graph that is skinnier than the graph of y equals absolute value of x. Write that down. Y equals absolute value of x. This is very, very true. Okay. And we also want to comment on the nature of our graph. We say if A is greater than 0, or if it is positive, okay, we could say it opens up. So that'd be a graph like this. Whereas if A is negative, less than 0, opens down. And so I'm going to write myself a little note here, and I think you should too, but it behaves, this A value behaves like a slope. It tells us the slope of the right side of our graph, okay? So we need to discover what H and K necessarily do, and we may need to flip over to another canvas, but I think it'd be valuable just one time to kind of maybe explore what happens if we start messing with like K. So what if we said, okay, so y equals absolute value of x. We're going to leave our A value as 1. Okay, we're just not going to mess with that this time. But what if I said y equals absolute value of x plus 2? All right, so just this once, we'll make a table. We say xy, negative 2, negative 1, 0, 1, 2. So, we'll pick up on the pattern here, but let's go ahead and get started. We say, well, if I plug in negative 2, that's the absolute value of negative 2 goes in for x, and we said plus 2. That's 2 plus 2, we get 4. If I plugged in negative 1, well, the absolute value of negative 1 plus 2, that's 1 plus 2, that's 3. If I plugged in 0, we get the absolute value of 0 plus 2. 0 plus 2 is 2. Absolute value of 1 plus 2 would be just, again, 3. And then this one down here, you notice we're going to get 4. So now if we sketch this graph and we say, well, originally when we look at the absolute value of x, this is this graph that is at negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 1, and we have this v, okay, v. This graph up here, we'd say was at 0, 2, 1, 3, 1, 3, 2, 4, okay, here and here. So you'll notice it's just our original graph, and you might just say this, well, it's kind of been shifted up twice, and that's exactly what's happening. This k value is going to control vertical shift, vertical translation, we say. So just to kind of play around with this, we'll go back over to here, and we say, all right, let's kick everybody out. Delete, and we'll start again from fresh. So we say, look at the original graph, y equals absolute value of x. There she is. What if I said y equals absolute value of x? Plus 2 was our next graph. We said it shifted up 2. We might imply from this, if I did absolute value of x minus 3, then it'd be down here. But what I want you to notice really is this. The plain old graph we said of y equals absolute value of x, okay, had an h value of 0 and a k value of 0. We're messing with k in this instance over here, k. But basically, that told me where the vertex was, to be honest with you. And when I'm messing with k this time, you notice that it's shifting my graph up and down. So really, that k value is affecting the y value of my vertex. Going back over here, we say, okay, so look at the original vertex was at 0, 0. When I put plus 2 on the outside, now it's at 0, 2. That 2 is like the new y value of my vertex. And when I put minus 3 out here, you notice the vertex is at 0, negative 3. So if up and down shift is controlled by this number on the outside that we're adding on to the end of our absolute value expression, then basically that just tells us where the y value of our vertex is going to be. Okay. Building on this, we're going to start again from fresh and say, well, what if we started messing around with the h value? So absolute value of x. Again, where was h? H is this number on the inside of the absolute value bars with the x. So if I were to now say not the absolute value of x, that plus 2, but the actual y equals absolute value of x plus 2, and I'll put the plus 2 in with my absolute value bar. You can see this up here on the left here. You'll notice that my graph actually shifted left 2. Now hold on a second here. When I put plus 2 on the outside, it made it shift up 2. That makes sense because, plus 2, up 2. When I put a plus 2 on the inside here with my x, it actually made it shift left 2. Left 2. That's weird. So what if I were to put minus something? Y equals absolute value of x minus 5. you would think that it would shift left 5. As a matter of fact, though, it shifts right 5. Okay, so this original vertex at 0, 0, well, the vertex of our second graph here was at 0, or excuse me, negative 2, 0, negative 2, 0. And the vertex of the third graph is at 5, 0. So when I put minus 5 in here, that actually made the x value of my vertex positive 5. And when I put a plus 2 in here, that made the x value of my vertex at negative 2. So that h value is going to control left and right shift of our graph. Okay, so I think we need to generalize this now, and then we'll do another quick video where we'll just start graphing a bunch of these, and they'll make more sense. So we say in general. I know I made that graph on the other page, but we're going to supplement this information. So what am I saying? I'm saying all this information in green right here. Okay, we're building on this. I've run out of room, so I'm going to write the rest of it over here. But we say this is very, very true. Given anything of this form, anything of this form, plus k. A couple of things I want to write. H is left, right, shift, or trans. Oh, I'm getting my words mixed up. I started writing shift. Left, right, shift, or translation. So this shifts left and right. And by the way, it is a liar. Okay, whatever it tells you, it's actually going to shift the other way. And we noticed that k was up, down, or vertical translation, vertical shift. Okay, so that shifts my graph up and down from the original y equals absolute value of x, and it tells the truth. So in general, here's what we want to write in green to build on our list over there. We say the vertex always at is always at v. I put a v out front. H comma k. H and k tell us our vertex, and that's how on the original graph over here I said, well, if h and k were 0 and 0, then I know the vertex of this must have been at 0, 0. So this is always true. And we say the axis of symmetry is always at the vertical line x equals h, and that makes sense. Remember, the axis of symmetry runs right through the middle of the vertex there, and so that is a poor line, but we say it has to share the same x value as the vertex. Okay, so this is a brief kind of run through of the basic shape of absolute value and how h and k and a kind of affect our graph. In the next video, we'll just take a look at graphing a bunch of different transformations and see if we can pick up on the patterns.